Alright, so today we got some warm-ups. So if you're on the video, you can pause it and try them. So the first one is sketch, find the domain, find the range. Name the function type. Is it even or odd? And name the zeros. Alright, so this would be pretty much a standard quiz question once we really start rolling, okay? The easiest one, hopefully for you guys, is that this is a rational expression, or a rational function. Okay? It is polynomial over polynomial. I know it's two terms, alright, but it's rational. It's not a composite, okay? It's a rational. Even odd, I got a really strong guess it's neither. I don't think it's going to be symmetrical any which way around the origin or the y-axis, so I think it's neither right now. I will tell you I know the domain right now. It's all reals except x can't be -3 because that's the vertical asymptote from this portion of the function. Those are pretty straightforward, okay? If I come over here then, you should be able to think to yourself, the mother function is 1 over x. That is the mother function. You need to have a feel for that. Two things happening. It has a left shift, a down shift, and a flip. And a flip, right? Because it's negative. So, I would think to myself, and if you need to sketch that, that's fine, but for the sake of board space, I'm going to get rid of my curves. And I know it's -3 for the vertical asymptote. I know it's down 1. So my horizontal asymptote is -1, and then I know it flips. Now, I do it in green so it stands out.
My bad, boys.
Now you can really confirm this by putting 0 in for x, and seeing that you get, if you put 0 here, you can see you get -1 2/3, -2/3 minus 1. So I feel really good about my graph, guys. I feel really good about my graph because that's that. Alright, and so my range up here, and again I'll go back to red, my range is y is all reals except y cannot be -1 because we know that from the mother function. And finally we took care of the sketch, domain, the range, the function type. Guys, look at this. You do not have to substitute f of -x this time. Okay, because we look at it, and I didn't tell you to prove it was even or odd or neither. I just said, is it? This is absolutely positively neither. It has no symmetry. If this had symmetry, this curve would be here. Does everybody agree? And if it was about the origin, oh my gosh, I don't even want to try to sketch. It's not even close to about the origin, so I'm not even going to show you, okay? It does not veer across, okay? This point right here would have to be up in here for that to work. Okay, the hard one actually is zeros. I know there's a 0. I'll do it in purple. I know there's a 0 right here. I could try to guess and check it. That sounds painful. Do you guys agree? So I would just make y equal to 0 in this equation. So 0 equals, you know what? Well, I'll do it in 2 steps.
1 equals.
So 1 equals, yeah, I was going to say let's skip that. I'm going to erase the 0 and erase the 1, the -1, and let's put that over here. Guys, I would cross multiply. I wouldn't just write 1. I'd go 1 over 1 equals -2 over x plus 3. So in my head, I can cross multiply. X plus 3 equals -2. -5. So the 0 is, it happens that x equals -5. I agree. And we have found a lot of cool information about this function awfully fast. Alright? So there we go. Alright, everybody. I think number 2 is tough. Alright, depends on how much practice you did in this in pre-calculus. Juda, we have not done much practice of this all. So what you have to realize is the English. And I got an underline here today. We got 3 things going on. We got red, blue, and green on the board. Knowing that a cube has a volume of length cubed, LG cubed. Sorry, if you ever...
I thought it was 2 different variables.
Oh, no, it's a cube, so the sides are the same. And surface area surface area of 6 length squared. I made a see, this is why I was in a hurry. Of 6 length squared. Write volume in terms of surface area. Everybody, what you need to understand, I'm going to get rid of this, is that, I'm going to correct my mistake before you guys catch it, is that you have 2 formulas. You guys know that for a cube, it's L by L by L. The volume is L cubed. if we were to make the net of said cube, right, unfold it, we agree each of the squares is L by L. There's 6 of them, so the area is 6L squared. So I gave you, and I did a bad job, so if you screwed this up, yell at me. I forgot to put the 6 here. So now we have the volume as L cubed, we have the surface area as 6L squared. But I want volume to be in terms of area. I want volume, some numbers, and then just an A to some power. I don't want the volume to be based on L, I want the volume to be based on A. Alright, we need this quite often, and since this is, I believe this is the first one we've done this year in calculus, right? We haven't done one of these yet. I think this is what I've been dropping every day because of the technical problems. So I'll work through this. That is our goal. Everybody, what do you know? Right now you know that volume equals L cubed if I drop the function notation. Does everybody agree? So if I'm going to get rid of L, right, what do I want to have instead of L for a variable? I want A. So everyone, I look at my other blue formula and I'm like, hey, I got a formula for A. You guys all agree with that? If I drop the function notation on the blue? So I want to solve it for L. So let's divide by 6. Everybody with me? And how do I solve for L? Take the square root. Why doesn't it have to be plus or minus this time?
Because it's like real lengths.
It's a length. I'm not going to have to go a negative distance. So even though really it was plus or minus, we can kind of just ignore the minus. Everybody with me? We know it's positive. Alright, I don't know how much of a crazy person your math teachers were. I was pretty nuts about rationalization, everybody. You know, that I can't have the square root of 6 on the bottom. But in calculus, drag your feet on rationalizing. Don't rationalize L. Did I ask you to solve for L in the problem? No. Don't rationalize to the bitter end. Everybody with me? So now, I want to write, I don't want L in this one, I want A. So if I substitute, and now we're going to get green color, volume equals Raqte cubed, square root of A over 6. Is everybody with me? Everyone, I want to make sure we think of it this way. It's A over 6 to the half power. Does everybody agree? To the third. So my V of L, and I'm not going to rationalize this today. That's just basic math stuff. I don't want to waste time. It's A over 6 to the 3 halves. And now it's not V of L. That's the wrong notation, right? Whoops. It now is V of A. I find the volume based on you giving me the surface area. This would only work for what? A cube. It would only work for a cube. Think we developed it for a situation. That happens a lot in calculus. We end up making equations that work for just one thing. This would work for all cubes. But a lot of times we'll have rectangular prisms and we'll tell you the length is twice the width. Well, once you get an equation at the end, if the length was 3 times the width, that equation would no longer work. Does that make sense? Everybody kind of think about it. Very specific places, okay? All right. We will work one of these every couple days until we feel pretty good about them, all right? We'll work one of those every couple days. All right. New stuff. Let's talk new. All right, so I have a function. F of x equals x cubed minus x. Find the average rate of change for the following intervals. 1 to 4, 1 to 3, 1 to 2, 1 to 1.5, and 1 to 1.1. Woofed up. Does that seem like a lot of work? It should. Everybody, what kind of, if you don't know, that's okay, but what kind of function is this? Anybody know? Up here, this one.
Wow.
What type of function? Haley, Brandon, Hunter, you guys know maybe? It's okay if you don't. We whipped through that section. Quiet falls. I'm trying to wait. How about a polynomial? It's not a power function, guys, because that's y equals x cubed. It's got extra stuff. This is the polynomial function, everybody. All right? You think it's even or odd or neither, as long as we're talking our way through it? It is odd. X cubed minus x to the 1. The powers are both odd. I can prove it. That's not the question this time. I will tell you the domain is all reals. I will tell you the range is all reals because we should all be able to picture the mother function that looks like this. And I know negative x is going to make it do some funky stuff in the middle, but it still is going to go to all reals for x and y, okay? That's why mother functions help set stuff for us. I could easily find the zeros. I know I'm taking some time on stuff it doesn't ask. The zeros are 0 and plus or minus 1 because we could factor that. Is everybody with me? So there's a lot of information here. I'm not going to... But what I asked is for the average rate of change. And if I had a page and I go dual page, it probably is worth our time to take a second and think to ourselves, it's odd. We know the zeros are here. We know it goes something like this. That function looks something like this. And everyone, if I plug in 1, you guys all agree that f of 1 is 0, right? I plug in 1 up here for the function. That f of 1 is 0. Nice and blue. And that is the start of all our intervals. That point, f of 1 equals 0 is where all these average rates of change start. And then f of 4 this time is 60. I plugged it in before class. So I'll do it. So f of 4 is 60. Man, that's like, I gotta be careful. That's like way up here. In fact, I probably need to make my curve a little better so it really kind of shows it, because this thing just launches itself. Okay? So, and f of 4 is 60. Well, actually, that's not the scale. Not even close to scale. F of 4 is going to be like, 4 is going to be like over here. It's going to be like way off the board. But everyone, I'm asking for an average rate of change between 1 and 4. Ooh, it's going to be something really steep, right? All right. My question to you guys is, what kind of line is this going to be? Say it nice enough so they hear you at the other end.
Secant.
Secant. 2 points on the line. Guys, average rate of change is secant. An instantaneous rate of change would be tangent. Tangent, that's okay. And we would pull 4, the point at 4, we would make this 4 come back to 1. Does you guys see what I'm doing here with that point? What am I doing? I'm actually pulling it back. These are all secant lines. And I want to be clear. I found these 2 points right here. Does everybody see them? I'm moving them around. Woo, now they're not one thing. There we go. Everybody, you don't have to do what we're about to do. I'm going to show you the way to do 1 point. If I just had to find, if this assignment, if this question was just this, just one case, we would absolutely do it the way I'm about to do it, which is, hey, I want to find the average rate of change. I know it's the slope of a secant line. It's 60 over, yeah, so it's 60 minus 0. You whispered the number, I heard you. Nice try to whisper, yeah, correct. Guys, the average rate of change from 1 to 4 is 20. And we could do it just using the points. Is everybody with me? I don't let you do that. What I do is 2 things. One is I give you enough of these that sitting and figuring out all the points takes time. If you were to do this, okay? If you make some math mistakes. But you can always do this to check yourself. Just take the 2 points, right? Plug in 3. In this case, it probably is faster to do it this way. But I want us to think about it in the method we've been talking about. And what I mean by that is, yeah, we know this answer is 20. Is everybody with me? For Roman numeral 1. The rate of change is 20. And I don't have any units on the graph, so there's no units on this number. If I told you this was feet and seconds, it would be 20 feet per second. If I told you this was miles and this was minutes, this would be miles per minute. Maybe it's a jet fighter. You thought I was going to write hours, okay? Don't know, but I didn't give units, so there are no units on my average rate of change. Everyone, I'm going to get rid of this graph, the actual graph of it. I'm going to push these points out of the way. And I'm going to just say, hey, I know that I am going to be given an interval.
We should have recorded the back screen so you're not in it.
Oh, but I like being in it. I got a real arrogance. I want Trent to see me. All right, A, you're probably right. Not changing it now. Everyone, I want you to picture, and I don't care what the curve looks like. That's not even close to the real curve. But I want you guys to picture that every time we have an interval from 1 to 4, it's really A to B, but instead of going B, we're always going to go A plus H. So we can, all right? It is B. Could go A to B, F of A to F of B. But I'm always going to do it this way, all right? And if we set up the equation for the average rate of change in terms of variables using F of A plus H minus F of A for the change in the y for the numerator, all over A plus H minus A, which we all know is just H. We will develop an equation based on A and H that will give us all 5 of these Roman numerals as fast as we can plug and chug the numbers. But that means that we have to go through the function notation of this. I don't even need the graph. I just want us to picture this. And I want us to picture that this rate of change in blue is this red equation down here. Okay? And we'll talk about the A's and H's compared to the intervals we're given after we develop this. So my first step over on this board is to recognize that F of A plus H is A plus H cubed minus A plus H. Everyone, if you're struggling with this function notation, review now. Review now, because pretty soon I'm going to throw up Pascal's triangle and literally skip all the algebra of this. I'm going to do a little bit of algebra today to keep us refreshed. But my expectation is we should be able to draw Pascal's triangle to the third line, know the coefficients are 1, 3, 3, and 1, write it out, and move on to the next step. Now I know that we got to review this a little bit today, but we got to get efficient at it because we can't waste time on algebra. Long term. Long term. F of A, I'll do in green. We know F of A is easy. It's A cubed minus A. And we know the bottom's H. So I'm going to expand the blue, and I'm probably going to go to a single screen to do this so I have some room. We'll come back to this problem in a second. Alright, and actually I don't need the graph, so I'm well, no, you know what, that would help you guys in a second. Let's keep it. We'll make it one thing. Let's make it small. We'll put it over here, okay? That allows me to move all this crap to the top. Alright, so we know what F of A is. Alright, if you remember Pascal's triangle, it's 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. This was A plus B to the 0 power, right? Anything to the 0 is 1. This is A plus B to the 1 power, which means it's A plus B. And the 1 and 1 are the coefficients, right, everybody? Remember? And then A plus B squared is 1A squared plus 2AB plus B squared. So the coefficients are 1, 2, 1. So for A plus B cubed, coefficients are 1, 3, 3, and 1. And you always go this way. So it's to expand this, and I tell you what, let's not do A plus B, because it's what? In our problem. It's A plus H. Let's just do H right away. So it's A cubed plus 3A squared H.
Plus A squared H.
3AH squared,
Yeah.
plus H cubed. So everyone, when we get to a point, very quickly here, what I'll write on the board, okay, and we'll save this, I'll start from scratch. What I am going to do very quickly, and if you need practice at that, this is fine, but you're going to definitely want to use it in your homework. I will do this. I know this is 0, 1, 0, 1, 2, third power. And I will literally write out then this. F of A plus H. I will write out A cubed plus 3A squared H plus 3AH squared plus H cubed minus A minus H. And it will be that fast since I picked up the red pen. And I know that's tough, right? So it's going to take a little practice. Tristan, especially for you, I don't know how much Pascal triangle we did, you and I.
Yeah, that would be about 0.
About 0. So we'll work on that. You're going to have to make some flex time. All right, but we'll get there. And right now, if you go A plus H times A plus H times A plus H, you'll get this same thing. You're just going to take longer. And that's okay. Time's not really that much of a factor in my class when it comes to testing quickness. Everyone, do we all agree with that huge disaster? We should all agree with that F of A is A cubed, that's a 3, minus a. I have all the information now. Let's write it out in black. A cubed plus 3a squared h plus 3a h squared plus h cubed minus a minus h. That's f of a plus h. Minus, now everybody, it's minus f of a. So all the terms have to change signs. Remember, the negative sign must distribute. This is a very common error. Alright, so it's going to be minus a cubed plus a. Does everybody see that? That's an a. Yeah, it's an A. Your double check, Black Hawk and Albany, is the simple fact of that if it's a function, this is, all the terms that do not have h should cancel in the denominator. If they don't, check your math. Don't just throw them away. That is a poor idea. Typically, if they don't match up, you've made a math mistake on other parts also. That said, I do not want to factor the h out, but every term that's left has an h, at least one. And when we factor an h out and cancel it, so instead of 3a squared h, we get 3a squared. Instead of 3a squared, you get 3ah. Instead of h cubed, you get h squared. Instead of minus h, it becomes minus 1. And I think I said at the beginning, it might have been faster to just do 2 points and, like we did with 20. But now, we have a formula, everyone, based on a starting point of a going for a duration of h that will give us the average rate of change for this function between any 2 points. So I go back, so if I copy this, I can remember it. I can go dual page for a second. Let's do it this way. So if I come back to my other page and I go all the way down, and remember, we got to kill lots of trees in calculus. It's good. All right? It makes you really smart, and someday you'll save the world because you know calculus. So we got to kill lots of trees today. Everyone, this black formula will now give us the average rate of change starting at point A, lasting for h. Everyone, do you notice that a is always the same for 1 through 5? So first thing I would do is say, hey, I know a is always 1. Let's simplify this equation some.
3 plus 3h plus h squared equals 1. 2 plus 3h squared plus 3h plus 2.
I just put it in order. Now everybody, now I've made an equation for these 5 Roman numerals starting at 1, and all I have to do is put in the h. All right, see if I can make this all fit. Yeah. Because I want to see them. All right, everybody, trick question. What's the h for Roman numeral 1 at the very top of the board?
20.
You're right, Kevin. Say it loud.
5.
No, I thought you said something else. I lied. I put you on the spot. My bad. Anybody, Albany, Monticello, or Blackhawk, Albany, Black, anybody out in TV land? Does anybody know H for the first one up here?
3. Where's the graph?
Hang on. Okay. 3.
I just said that.
I know, but I didn't want to give you credit. It took you too long, and Haley was brave. Everybody's 3. If we go back to the graph, yes. Let's go back to the graph, nerds. You know that's why I saved it. All the way back up. And I don't care about all the calculations anymore. This is all just transportation. Everyone, the first point on this one for the first one is 1. This is 4, but it's 1 plus h. 1 plus h equals 4. The duration is 3. Everybody, if I come here and I put in 3, and I'll just do it next door, 3 squared plus 3 times 3 plus 2. Is that 20?
Yes.
It sure is, unless you get 6 for 3 squared. And everyone, I bring up these jokes because this is the stuff that kills you guys in calculus. It's those type of mistakes that get us, okay? So the answer is 20. Everybody, what's the h? Everybody in your heads, think what h has to be for this one. 3, 2, 1. What is it? 2. Plug it in. 2 squared plus 3 times 2 plus 2. 4 plus 6, how about 12 is the average rate of change of Roman numeral 2. Again, no units because I didn't give units. The next one is 1, right everybody? Is it 6? Now the next two are a real pain in the butt. 0.5. Ugh. Alright, and this is where I probably want a calculator, but
3.75.
1.5. Yeah, 3.75, right on. Good catch. Alright. Everybody, let's do this one. .1 squared plus 3 times 0.1 plus 2. This is 2.3, you guys agree? 0.1 squared is 0.01. Yeah, 0.1 times 0.1 is 1, 2 decimal points is 0.01. So how about 2.31? And if you have to get your calculator for that, I get it. I mean, I'm just old and done a lot of math. All right. And someone probably sitting there saying, Anderson, you can't force me to do this. This is horrible. I'd much rather use 2 points like you did on the first Roman numeral. But I always put this last one on the test. Always. And it's always the sixth one. So if you go to all the work to do the first 5, that's the first one you did. That's what we did over here in terms of variables. And the answer to Roman numeral 6 is this. Right? The equation we developed goes from a to a plus h. Okay? Everybody, we started at 1. Does anybody think they know the instantaneous rate of change at 1? Does anyone think they know the this is all average. Does anybody think they know the instantaneous rate of change at 1 or can figure it out here? Yes. Now, did you do it from the numbers going down? That's okay. Or did you do it different? How'd you do it?
I took the difference between 1 and 1 is 0, and I put it into the equation.
Okay. That works too, actually. I'm going to teach it a different way. You're right. Ignore what Justice said, though. Because there's an easier way. Everyone, if you're going to pull that point that's way over here, if you're going to pull the point at a plus h back to a, what's going to happen to the value of h? It becomes 0. Guys, what if you put in 0 into this equation at the very bottom? 0 squared plus 3 times 0 plus 2. 0 plus 0 plus 2 is 2. The instantaneous rate of change at a equals 1 is 2. Alright? Again, is that a lot to sink in? Absolutely. Is it a lot of work? Yes. But this is how we look at our functions. And right now, usually what students need to practice is the function notation side of it. Does that make sense, everybody? I really honestly do get that it's a lot easier if you have a single point to do that. So you have to make a decision every time these show up on quizzes, especially for you guys doing the AP. Because if this was a multiple choice question, there is no, and it was just Roman numeral 1, it is a waste of time to do it this way. You should do it this way. But if you get to the free response, it almost always makes sense to do it the Roman numeral 6 way. Okay? And again, this comes with time and practice. I make you, listen, let's go right to brass tacks. There's a huge advantage for us understanding the idea of a duration and pulling point Q back to point P. Changing a secant line into a tangent line by making the space between the points 0. Does that make sense to everybody roughly? And I am going to say that phrase and that picture here 9,000 times between now and the end of the first quarter. Alright? So I am going to pull point Q back to point P by making H go to 0. Does everybody follow me? And that changes the secant line PQ into the instantaneous rate of change at point P. Alright, we'll get lots of that. Again, this is a pretty good example. This comes out of 2.1. If you're thinking, where in the book are we? I want to read somebody else's ideas on this. The book spends a lot more time on this method initially, but but I spend a lot more time on a to a plus h. That comes up in the beginning of chapter 3. We fly through the first part of chapter 3 because we spend a lot of time right now in 2 doing this. I want us to see it in terms of variables. Okay? All right. I'm cruising 6 minutes. All right. Let's introduce the last thing of the day. I don't graph stuff wrong on purpose, so I copied this from the book so I know it's right. It's a parabola. Everybody in here, if they think about it, should say, oh yeah, negative 1 divided by 2, so it's half to the right. You should be able to see that if you were going to try to write this in its general form, you'd have to complete the square and figure out what the blank is, but you knew it would be half to the right because of the coefficient on the middle term from our days of graphing parabolas and pre-calculus. That said, I don't particularly care because I had the graph. You notice all of a sudden I show you that it has an axis symmetry at x equals half. Everyone, is this an even function? No. It's not symmetrical about the y-axis. It's symmetrical about the axis of symmetry, which is at x equals half, which is not the y-axis. The y-axis is x equals 0. All right, and I said, hey, what's f of 2? Well, I assume you guys can do this work, so we're going to put 2 in here. 4 minus 2 is 2, 2 plus 2. Everyone, do we all agree it's 4? All right. If I blow up, and let's see if this works. Yep. No, if I blow up this picture, and I'm going to lose the function. But I could look, and does everybody in here agree that this is 4 for a y value? Because this is where the point is. And this is the 2, which we see. All right? And as I come up the values, what do we notice? As I get closer and closer to 2 in the x value, I'm getting closer and closer to 4. And and this function is, if you're traveling from the left to the right, I'm getting closer and closer. The value's getting bigger and bigger. So, whoops, that stupid half's in the way of my table. Yeah. Did I fix it? That helps. And what I want you to notice, and ignore the red mark, is at 1 it's 2, and at 1.5 it's 2.75, and at 1.9 it's 3.71, and at 1.95 it's 3.83, and at 1.99 it's 3.97, and at 1.999, right, it would be super close to 4. Do you guys agree? Like 3.99? So as I come up from the left-hand side to the left-hand side of the value, as I come up the left-hand side, I'm getting closer and closer to 4. Big surprise, right? If I come from the right-hand side, this way, I'm traveling this way, we'd expect the values to slowly get smaller, right? So if I look at a table of those, at 3, up here it's 8, at 2.5, 5.75, 2.1, 4.31, at 2.05 it's 4.15, or 4.16, at 2.1 it's 4.03. Well, here's what I'd like you to see. Do you guys agree that those are both 100th away from 2? And what's the difference in the y value? 300ths, you guys see it? And as we're coming in from both directions, we are closing in on the value of 4 this time. Everybody, this idea of closing in on a value versus finding the value is the idea of a limit. Okay, because there are times that we have points that do not exist, and we're very interested in what's happening. And what I mean by that is this idea. And I think we graphed this, and usually I have this lesson 2 days after we did this graph. I know for a fact we did this graph. It was a rational graph with a hole. Because I do this graph every year with the students, okay? Because I'm trying to prove a point when we get to this point. We just had a graph where f of 2 was 4. Everybody, what is f of 2 on this graph?
4.
But it's not. Thanks for playing. F of 2 is what? F of 2 is undefined. Hang on, I'll finish this thought. I know the bell just rang. Just hang on 1 second. Everybody, it's undefined. If you write f of 2 equals 4, I am going to cry on your paper. It'll be water stained. Alright? It is undefined. But justice is right. Man, oh man, we can see. We can see what's happening here. So what's happening as you come up from the left-hand side? It is getting closer and closer to 4. What's happening from the right-hand side? It is getting closer and closer to 4. In fact, the limit as x approaches 2 is of the function on the board, which we'll call f of x, is equal to 4. Everybody, the function is undefined at 2. But as you come down the bunny trail from the left-hand side, and you come down the bunny trail from the right-hand side, where do those two rabbits collide? At 4. And that is a limit. And that's a point we're interested in, so we know how to graph. So everybody, can everybody see what I mean? Because now I literally can say, hey, I got a function that's undefined at 2, has a limit at 2, and the function is y equals x plus 2, except x can't be 2 on the domain. Everybody, in 2 seconds now we can graph this whole thing. And we can define the interesting part. Guys, the only thing interesting about y equals x plus 2 is the hole in this graph. There's nothing interesting about a line. Send you back, go grab a freshman, Hunter, and make him do lines for you. Alright? There's nothing interesting about them. We're interested on that stupid hole. Is everybody with me? Alright. Homework, homework, homework. That's it. Do it. I got Hunter, I put yours in. Brandon, I put all yours in. Yes, I doubled up the questions. Guys, I made a mistake and I referenced the non-question twice. That happens. You don't ever have to do anything twice if I make that mistake, okay? Alright, turn the camera off. Bye-bye. Calculus is fun.